In this problem, we want to find the relative extrema for the function f of x. I'll start by finding the first derivative, and we'll use the quotient rule, so that's the denominator, times the derivative of the numerator, which is 4, minus the numerator, times the derivative of the denominator, which is 2x, and then that's all over the denominator squared. So now let's simplify the numerator. I'll start by distributing the 4, and I get 4x squared plus 4, minus, and then I can multiply the 4x and the 2x and get 8x squared. And again, that's over x squared plus 1 quantity squared. And finally, the numerator is equal to negative 4x squared plus 4 all over x squared plus 1 quantity squared. Now we know that the denominator can't equal 0 because we have x squared plus 1 in the denominator. So I'll just be setting the numerator equal to 0 and solving for x. So I'll shift this all up. So I'm just going to look at negative 4x squared plus 4 equals 0. And I could use factoring, but in this case I think it's easier just to subtract the 4 over, divide, then I have x squared equals 1, and that gives me x equals plus or minus 1. As long as you're going to remember to use the plus or minus when you take the square root here, I think that's the quicker way to go. So now I have these values 1 and negative 1. So let's plug them into the original function, find f of 1, and that would be, let's see what the original function was. Okay, so 4 times 1 over 1 squared plus 1. And that's 4 over 2, so that's a 2. So that gives us the point 1 comma 2. And then f of negative 1 is 4 times negative 1 over negative 1 squared plus 1, and that gives me negative 4 over 2, so that's a negative 2. So that's the point negative 1 comma negative 2. So if I want to see if these points are relative maxes or relative mins, I can take a look at the graph of the function. And the graph comes out looking like this. So we can say that 1 comma 2 is a relative max, and negative 1 comma negative 2 is a relative min. And that's the end of that problem.